In this video, let's look at another machine learning algorithm called K-nearest neighbor or KNN algorithm. The K-nearest neighbor is a supervised machine learning algorithm that can be used for both classification and regression. In this video, let's understand how K-nearest neighbor works for classification, and in the later part of the video, let us understand how it works for regression. So now let us consider a data set like this. Consider this to be a binary classifier dataset which has two categories. The red points belong to a separate category and the green points belong to a separate category. In K nearest neighbor, we will be having either a binary classifier or a multi-class classifier. So for consider this to be a binary classifier, and we have a query point here. Now our objective is to find whether this particular query point belongs to this red category or it belongs to the green category. In K nearest neighbor, the value K is the number of data points. That is, K is the number of nearest neighbor that will be checked to determine the particular class of the query point. Here we will be considering 5 points. Let us consider 5 points that is nearer to this particular query point. Here these 3 points from the red category, that is these 3 points are nearer to the query point from the red category, and these 2 points are nearer to the query point from the green category. So it is obvious that more data points from the red category is nearer to this particular query point, and 2 data points from the green category is nearer to the query point. So the number of data points from the red category is more, which means there is a possibility that this particular query point may belong to this red category. In K nearest neighbor, it is purely based on vote. Since the number of votes from the red category is more, so it will be decided that this particular query point will belong to the red category. So what happens if I choose the value of K to be 3? Since here we had 5 data points, we can easily say that these 3 points belong to the red category and these 2 points belong to the green category. So now let us consider the 3 points. So what happens is it calculates the distance between these data points. So the minimum distance from this point will be obtained, and the second minimum distance and the third minimum distance. Consider this to be the third minimum distance. So what happens here? Here, 2 data points from the red category are nearer to the query point, and one data point from the green category is nearer to the query point. So again, it is obvious that red category has more votes than the green category. Red has 2 votes and green has 1 vote. So it is obvious that there are possibilities that the query point belongs to the red category. The point to be noted is the distance between the query point and the data points is the main thing that determines the category of this particular query point. From this, we can understand easily that classification in K nearest neighbor is purely based on the distance between the data points and the query point. The K nearest neighbor will be looking like something like this. Here we can see that green is the query point and we have 2 different categories. Blue colored data points and orange colored data points. These 2 are different categories. You can consider as blue as yes and orange as no. Now we have a query point here. So to which category does this particular query point belong? Now we will be calculating the distance between the data points. Here the minimum distance is from these 2 points and this particular orange point. These 3 are the nearest neighbors that has the smallest distance between them. So it is obvious that this query point might belong to blue category since there are more data points nearer to it. Here we chose the K value as 3. So it belongs to blue category. Hence we can confirm that this is purely based on distance, and now let's get how to calculate this distance. To calculate the distance between the data points, there are 2 major methods called as Euclidean distance and Manhattan distance. The Euclidean distance is given by distance is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Consider a data point like this here and here. Now we have to calculate the distance between them. This is x1 and this is y1, and this is x2 and this is y2. To calculate the distance between them, we can obtain this from this particular equation. We can also obtain this using Pythagoras theorem. And for Manhattan distance, the basic principle is we have to find the distance between these x coordinates and we have to add the distance from the y coordinates. So if we subtract the x coordinate values from x2 minus x1, we can get the particular distance of this region. And if we subtract the y coordinates, we can easily get the value of this particular region. So if we add this particular region, then we can get the distance between these 2 points. So the Manhattan distance will be given by modulus of x2 minus x1 plus y2 minus y1. Since distance cannot be negative, we are giving this as modulus so that there won't be any negative values. This is how we can get the distance between the data points. These two are major approaches that we use to calculate distances. There are also another methods such as Minkowski and Hamming distance. We can choose which type of method we are going to use based on the scenario such that our data set and our features are present. So this is how we calculate the distance between the data points. And to be noted that here we can easily identify this particular query point belongs to K as there are more number of points from the red category is present near the query point. But what happens if K equal to 6? If K is an even number, there are possibilities that equal number of points from this particular category and this particular category may be present. So such that we cannot decide to which category this particular query point belongs. So it is always a best practice to keep the K value as an odd number. There is also an important point to note that to get the K value, choosing K value is one of the important steps in K nearest neighbor algorithm. Usually K can be obtained from a method called as elbow method. What elbow method states that is that we have to run different epochs for different K values such that we will be mapping error rate with K value. We will be getting a graph like this, where the x-axis will be having K value and the y-axis will be having the error rate. So this particular graph will be having a curve like this which looks like an elbow. We will be choosing K value from here, which will be the optimum value. To obtain this graph, we will be using various metrics such as confusion matrix or F1 score to analyze the error. And for different epochs, the slope will be gradually decreasing. So this particular point which represents the elbow will be optimal for choosing the K value. There are also several other ways to calculate the K value, but we will be focusing on this particular method. Always remember to keep the K as an odd number, or you can use K-fold cross-validation for evaluation of your model's performance on unseen data. This K-fold cross-validation method will also be used to calculate the value of K, and you can also use grid search where you can assign values for K as less value for small data set and higher values for large data set. And you can also use bias variance trade-off. For small k, we will be having low bias and high variance, which will be used for flexible data set. And for larger k, we'll have a smooth boundary with high bias and low variance. It will be looking something like this. Here we can see that k value is less, which means it has low bias and high variance. Here you can see that this particular red point is nearer to green points, but it is classified as an individual red points as the k value is less, and which implies high variance. So this particular red point is not classified as green point. So for different k points, we can understand different bias and variance combinations. So there are also several other approaches like grid search, bias, trade variant. Before you create a k nearest neighbor algorithm, it is also important to note that we have to do feature engineering for every model that we are going to create. So these are some important points to be noted. For choosing features, we have to follow certain approaches for k nearest neighbor. There is a concept called curse of dimensionality. In high dimensional spaces, the distance between the data points can be less meaningful, which implies if we have more features in our data set, that makes our data set to be generated in high dimensions. It may be 3D dimension or 4D dimension. In that case, it will be hard to calculate the distance between the data points. Since more features data points will be present in that particular plane, it will be messed up such that there will be many data points and it will be irrelevant to calculate the distance between different features. And as said, the irrelevant features should be removed from the data set. These irrelevant features will increase the complexity of our model such that the data points will be calculated wrongly. And we should also do principal component analysis for feature selection or dimensionality reduction. This principal component analysis plays an important role while pre-processing the data. That means before creating the data, we have to do principal component analysis and determine which are the features that are truly necessary to create our model. As we can see, this particular image represents a multi-class classifier. Here we can see different categories such that there are data points in blue color, red color, and green color. So what happens here? How to determine which data points belongs to which class? So there is a concept called one versus all strategy and one versus one strategy. Usually the KNN is inherently a binary classifier. It is suited for binary classification. But in real time, we might get chances to work with multi-class classifications. So what is one versus all strategy? For each class, we will be training a KNN classifier to distinguish a particular class from all other classes. That means we will be implementing a number of classification. That means we will be implementing number of classifiers equal to the number of categories present in the dataset. If we have three categories in our dataset, we will be creating three classifiers for that particular scenario. The one versus all strategy will be looking something like this. Consider this scenario. We will be having three categories. Since there are three categories, we will be having three classifiers. What this particular classifier do? In the first scenario, we will be considering triangles as a particular class and all other data points to be some other class. So this is one versus all classifier. So we will be doing similar things for all other data points. So the number of classifiers in this particular scene will be 3. Since there are 3 categories, we will be differentiating each category from all other categories. This is one particular method, and another method is 1 versus 1, where we create classifiers for each pair of classes. So the total number of classes will be n into n minus 1 by 2. In simple words, let me show you another example. Here you can see for each pair of classes, here you can see the square versus diamond for particular class, and the circle versus diamonds for particular class, and the another scenario. So respectively, if we see, we will be creating a number of classifiers to classify this particular data set. But we need not to worry because Scikit-learn directly supports multi-class classifiers. So what Scikit-learn actually does is that it understands automatically the scenario where multiple classes of classifiers are present. So this is all for classification. Now coming to regression, what k-nearest neighbor algorithm actually does is that consider all these data points belonging to a same category. So now we have a query point here. In regression case, what we actually do is we will be choosing a k value and we will be finding the mean value of the data points. Here, let us consider the k value to be 4. Usually, we will be taking k value as odd number. For example, consider here the case is 4. So, what we will be doing is that we will be finding the 4 nearest neighbor to the query point. Here, these 4 values are nearer to the query point, and what we will be doing is that we will be finding the values of these particular 4 points, and we will be finding the average of these 4 data points. That value will be our predicted value. This is what happens in the regression case of KNN. In simple words, in regression, the predicted value y cap is given by 1 by k into summation of I equal to 1 to k yi, where y cap is the predicted value and yi is the data points that we have. So let us consider example the value of k equal to be 3, and we have the data points as y1 equal to 4, y2 equal to 5, and y3 equal to 6. Consider these 3 points. This is 4, this is 5, and this is 6. And what we will be doing is that we will be having y cap is equal to 3 plus 4 plus 5 divided by 6, and we will be getting the value as 5. So our predicted value here will be 5. So we can also assign weights to the data points. In k nearest neighbor, we can assign weights in such a manner that weight of a particular data point is inversely proportional to the distance between the data points. If the distance is more, we can assign less weights to the data points. If the distance between the query point and the data point is less, then we can assign more weights. So let us consider another example by assigning weights. So consider a scenario like this, and we will be having k value equal to 3, and this is our query point. We will be having 3 data points that is nearer to our query points. Consider the value to be 4, 5, and 6. So the weighted average. So this particular weighted average method's predicted value is given by y cap is equal to summation of I equal to 1 to 3. Since value of k we given 3, weight of I into value of that particular data point divided by summation of I equal to 1 to 3 wi, the respective summation of the weights. So here we will be having the data points y1 equal to 4, y2 equal to 5, and y3 equal to 6. So the respective weights W1 will be, since it is inversely proportional, this particular value will be 1 by distance 1. The particular weight of the second data point will be 1 by distance 2. And the particular weight of the third data point will be 1 by D3. So let us have the value of the distances as 1, 2 and 3. We will be having values of the weights such as 1 by 1 will be 1 and 1 by 2 will be 0.5 and 1 by 3 for weight W3 will be 0.33. So this particular equation will become, I am applying these values to this particular equation, we will be getting 1 into 4 plus 0.5 into value of y2 is 5 and the third value 0.33 into 6 divided by the total summation of the weights 4 plus divided by the particular values of the weights, which will be 1 plus 0.5 plus 0.33. This particular equation will give us the value of y cap is approximately equal to 4.63. So this will be our predicted value. This is how we can assign weights to our data points. There are also several other ways to determine weights for each data point. There are several approaches to assign weights to our data points. This is a simple example that I gave to assign weight. You can also refer to the official Scikit Learn's website to know more about the hyperparameters and parameters of the k nearest neighbor and how it works. They have a well documented web page where you can refer to know the in-depth details that I haven't discussed. So that is all for this particular video. So let's implement a k nearest neighbor algorithm in the upcoming videos. If you have any alternative approaches or suggestions, please do leave a comment.